Welcome to my channel. Today we are going to discuss about the multiple choice question and answer from the classification of signals. So in the previous video we discussed the multiple choice question and answer part 1 from the standard signals. So here today we are going to discuss about the classification of signals. So from that part we are going to see the questions. Okay. So the first question you see, before that, the classification of signal. If you want to learn more about the classification of signals means, so I will give the link. Already video is there, so I will give link in the description box and icon also. So you go and verify it. Okay. So the signals are classified into basically two types. One is the continuous time signal, another one is the discrete time signal. Then all continuous and discrete signals are classified into further so many types. One is the periodic and non-periodic signal, energy power signal, then deterministic and random signal, okay, and etc. Okay, causal, non-causal, and even, odd signal, etc. So using that one, we have to see this one. So the first question you see, most of these signals found in nature are dash. Okay, so most the real-time signals are in which nature? Either you see the first choice, continuous time and discrete time. So no real time signal is available in a discrete time in nature. Okay, so the first one is wrong. The second one is continuous time and digital. Okay, so digital signal is not available in a that is a practical signal is not available in a digital format also. The third choice, digital, no. Then the fourth one, analog and continuous time. Yes, analog means it is also a continuous time signal. Okay, continuous time, continuous amplitude signal, it is called as a analog signal. So most of the signals found in nature is in which thing? Analog and continuous time signal. So the answer is D. Okay. So the next one, the continuous time signal is periodic if it should satisfy the condition. Okay. So which what is the condition in order to check the periodicity? What does mean by periodic signal? The signal which repeat itself after a regular interval of time. Okay. So after a regular interval of time, again and again, the same signal is coming means that is called as a periodic. So what is the condition in order to check the periodicity means? So first you see x of t equal to x of t plus capital T, where capital T is a one fundamental time period. Okay, this is the correct answer. X of t equal to x of t plus t. X of t plus t means after the time duration, that is the time period, again we will get the same waveform. Okay, this is the condition to check it is a periodic. Second condition, x of t not equal to x of t plus t. This is the condition for non-periodic. Then x of n equal to x of n plus n. This is the periodic condition for discrete time signal. Okay, so this is the non-periodicity condition for discrete time signal. Okay, so here the question is CT signal, continuous time signal, periodic. The first is the answer. Okay, then you see the next question. The discrete time signal is periodic if it should satisfy the condition, which one? Okay, the same thing. So x of t equal to x of t plus t is the condition in order to check the continuous time signal is periodic or not. Okay, so similarly, what is the one? X of small n equal to x of n plus n. This is the condition in order to check the discrete time signal is periodic. Okay, then the next question, the sum of two periodic signal is a periodic signal when the ratio of their time period is dash. Okay, that is in the question. What they are asking means the x of t signal consists of two signal x1 of t and x2 of t. So x1 of t, x2 of t, the sum of two periodic signal is periodic signal means what is the condition? That is the ratio of their time period. T1 by T2 ratio, it should be dash. It's a rational number, irrational number, complex number, integer, rational number. Okay. So that is so related this one. So we will see the problem also. Okay, so that problem that will ask in a 2-mark question. So this is the 1-mark question. So if the two signals that are the addition of two signal, it should be a periodic means the condition in order to check that addition, the sum of the two signal is periodic means the ratio T1 divided by T2. So it is a ratio of two integers. Okay, integers, that is said to be the rational number. Ratio of two integer, we are calling it as a rational number. Okay, so next one, a signal which repeat itself after a fixed time period is called as dash. Periodic signal, non-periodic signal, energy signal, power signal. So a signal which repeat itself after a fixed time period. After a fixed time period, again the signal repeats means it is called as a periodic signal. Okay, this is the definition for periodic signal. So answer is A. Next one, a signal which does not repeat itself after a fixed time period, it is called as a non-periodic signal. That is the example for the non-periodic signal is a exponential signal. Okay, so you see the exponential signal. The exponential signal is it starts from 0 at end at infinity. Okay, so the shape is not at all repeating after a regular interval. So that is said to be a non-periodic signal. Okay, so for periodic signal, the example is sinusoidal waveform. So after one cycle, again the same shape. Okay, so this is the one cycle waveform. After a one particular time period, again the same waveform is again and again repeating. So the sine wave, cosine wave, it's an example for periodic signal. Okay, so the exponential signal, signum function, these are all the example for non-periodic signals. Okay, then the next question, which one condition is true to check the periodicity for discrete time signal? Okay, so where k is any integer, n is a period, f naught is the frequency of signal. Okay, so here what is the condition in order to check periodicity for discrete time signal? If one signal, discrete time signal x of n is there means, so what is the condition in order to check the periodicity means, the frequency f naught, it should be the ratio of k divided by n. This k by n, it should be, okay, so here f naught is k plus n, f naught equal to k into n, f naught n by k. So these are all the wrong answers. The f naught is said to be the k divided by n. Okay, so if the k and n is a integers means that particular discrete time signal, it is a periodic signal. Okay, so this is the condition. Next, a discrete signal is periodic if its frequency f naught is a rational, ratio of two integers. That is this is the condition of this previous question. So a discrete time signal is periodic means its frequency f naught. So the frequency f naught, it is nothing but the rational number, that is ratio of two integers k divided by n. Okay, so this is the condition in order to check the periodicity of discrete signal. Whenever this k value and n value is a ratio of two integer means at the time only the discrete time signal is periodic. So the statement is correct or not? Okay, true only. Okay, so the option A. Then the next thing, which one is a discrete time periodic signal? Okay, so here that three thing is four condition is that sine 3n, cos 2n, sine 3 pi n, all of the above. Okay, so in this one, which one is correct? Okay, discrete time periodic signal. So already you know, in order to check the discrete time signal is periodic or not. So here you see what are the way, what is the signal given? It's a sine, discrete sine sequence, discrete cosine sequence. This is also a discrete sine sequence. Okay, so out of this, which one is a periodic? We have to measure. Okay, so in order to check the periodicity, so first we have to find out the frequency. Okay, the frequency f or f naught for the given signal by comparing the given signal with standard signal. Okay, so in this three thing, in the first two thing, in sine 3n cos 2n, okay, pi is not there. Okay, so in the third term, pi is there. Okay, so blindly saying if in one sequence, if in sine or cosine the pi term is available means it is a periodic. Okay, so here I will prove that one. So you take this third example, this 3 is the correct answer. Okay, so we are going to solve it for the third one. So first and 2 I will tell. Okay, so here the given sequence x of n is sine 3 pi n. Okay, so we have to compare this given signal with our standard discrete sine sequence. So what is the standard discrete sine sequence? Sine omega n. Okay, so when we are comparing this sine given x of n with the sine omega n, So in the place of omega, what is the thing is available? 3 pi. So omega equal to 3 pi. What is mean by omega? It's a radian frequency. So the radian frequency, it can be written as 2 pi f. So 2 pi f is equal to 3 pi. So here the pi, it will cancel. So from that, the f can be written as 3 divided by 2. Okay. So already you know in discrete signal, the frequency f, it can be written as a format of k divided by n. Okay. So already one condition given, you know, the f naught, it can be written as a ratio of two thing k divided by n. So that's why here this 3 divided by 2, it is k divided by n. So you see the k value 3, n value 2. So both k and n is a integers. Okay, so if the f is a ratio of two integer means we can say that the given signal is a periodic. Okay, so for this only we will get the f value as a ratio of two integer. So if you are solving it for the first sine 3n cos 2n means at the time, so you see for this first one, the omega value, okay, in the place of omega, what is the thing is there? 3 is there. So 2 pi f, the omega, it can be expanded as 2 pi f is equal to 3. Okay, so from that, so pi it will not cancel. So that's why the f can be written as, the frequency f can be written as 3 divided by 2 pi. Okay, so the 3 divided by 2 pi, so it is nothing but k divided by n. Okay, so here you see the value of k and n, k equal to 3, n equal to 2 pi. So you see what is the value of the 2 pi? The 2 pi is not an integer. Since the pi value, it's not an integer value, the product of 2 pi is also an integer. So the k is integer, but n is not an integer. So the f is not a ratio of two integers. That's why the first signal, it is called as a non-periodic. Similarly, the second problem is also non-periodic. Okay, since the pi term is not available. Okay, so simply saying if one sequence is given means in that discrete sequence, if pi is available means it's a periodic. Pi is not available means it's a non-periodic signal. Okay, so here the f value, it's a ratio of two integers. So the given signal, this signal is a periodic signals. Okay, so these questions are sometime 2 mark questions. Okay, so next one, if the x of n equal to cos n by 2, then the sequence x of n is periodic, non-periodic, depends on n, none of the above. Okay, so which one? So here you see cos n by 2. So here n pi is there. Okay, pi is not at all available. So that's why the sequence, it may be a non-periodic. Okay, so non-periodic only. So let us prove this one. So you see the given sequence cos n pi by n by 2, it is compared with the standard sequence. So the omega value equal to 1 by 2. So omega, if you are expanding, 2 pi f. So 2 pi f is equal to 1 by 2. So from that, that is f can be written as 1 divided by 4 pi. So k is 1, n is 4 pi. So k is an integer, n is it's not an integer. So the ratio k by n is an irrational number. Okay, so that's why the given, this signal is a non-periodic signal. So cos n by 2 problem, it's a non-periodic. Okay, non-periodic. Then you see the next question. If x of n equal to cos n by 2 plus cos n by n pi by 4, then the sequence x of n is periodic with the period 8, periodic with the period 4, non-periodic, non-periodic with the period 8. Okay, so we can check. So here in the previous two problem, we checked only, that is the given signal consisting of only one signal. Okay, cos n by 2 or only sine 3 pi by n and so on. But here the given sequence, it consisting of the addition of two cosine sequence of different frequency. So one is cos n pi by 2, the another one is cos n pi by 4. Okay, so if the addition of two thing means, in order to verify the given signal is a periodic or not, we have to find out the capital, the period, the time period n for the first signal separately, for the second signal separately. Then we have to calculate the ratio n1 divided by n2. If the ratio n1 divided by n2 is a rational ratio of two integer, we can say that periodic. Otherwise non-periodic. Okay, so that is the condition. So now we can check. So you take the first sequence, this cos n pi by 2 as a x1 of n, and cos n pi by 4 is a x2 of n. Okay, So the first sequence, it compare with the standard cos omega n. So in the place of omega, pi by 2 is there. Similarly, here in the place of omega, pi by 4 is there. So from this omega, so this omega, it can be expanded as 2 pi f1 equal to pi by 2. So from this, the f1 can be written as pi cancel. So f1 can be written as 1 divided by 4. So this 1 by 4, it can be expanded as k divided by n1. Okay, so from this, the n1 is equal to, okay, we have to find out the fundamental period n1. So the n1, we have to take it as a 4. Similarly, if you are comparing this second signal with standard thing, so omega 2 equal to pi by 4. So 2 pi f2 equal to pi by 4. So here pi cancel, then f2 can be written as 1 divided by 8. So it can be written as k divided by n2. So from this, what is the value of n2? n2 equal to 8. Okay. So if it is a 2 signal means we have to find out the n1 value and the n2 value. So after calculating n1 and n2, if the signal is periodic or not, in order to verify, we have to calculate the ratio n1 by n2. Okay. So n1 by n2, if this ratio n1 by n2, it's a ratio of 2 integer means we can say that the given signal is a periodic. So here what is the n1? 4. What is the n2? 8. So 4 divided by 8. So 4 is an integer, 8 is an integer. So that's why the given signal, addition of the sum of the two signal, it's a periodic signal. Okay. And so here the periodic, there are in two thing, periodic is there. But in the first choice, periodic with period 8. In the second one, periodic with period 4. So that's why we have to find out the fundamental period. So after determining it's a periodic, the fundamental time period of x of n, so you already know what is the fundamental time period of that resulting signal x of n. It is nothing but it's a LCM of n1 comma n2. Okay. So the LCM of what is n1? The n1 is 4, n2 is 8. So if you are taking LCM for 4 and 8, we will get the answer 8. So 8 is the fundamental period. Okay, so that's why the answer is periodic with a period 8 samples per second. So A is the answer. Okay, so this is the question. So in this way, we have to follow. Okay, this is the thing. If the two signal, if it is addition of two signal or multiplication of two signal, we can follow the same procedure. Okay. Then the next one, the period of the function cos pi by 4 t minus 1s. Okay. So here what is the given signal? The given signal is a continuous time cosine sequence. Okay. So we have to find the time period for the continuous time cosine sequence. Okay. So already you know all continuous time sine and cosine wave. Okay. Single sine and cosine waves are periodic signals. Okay. All continuous time, single sine and cosine waves are periodic signals. Okay, periodic signal. So from that, we have to find the period. So if we want to find the period, so first we just compare the given equation with the standard cosine sequence. So what is the standard cosine sequence? A cos omega t plus pi, where pi is an angle. So we want only the omega. So no, don't worry about that angle, any value. Okay, so this pi by 4 t minus 1 can be expanded as pi t by 4 minus pi by 4. So pi by 4 is an angle. So you just leave it. So when we are comparing these two things, the omega equal to pi by 4. Okay, so what is omega? The omega is expanded as 2 pi f. So 2 pi f is equal to pi by 4. So here the pi cancelled. Then the frequency f is equal to 1 divided by 8. Okay, so here the question is fundamental time period. So what is the fundamental time period? The time period is nothing but it's a reciprocal of the frequency. So 1 divided by 1 by 1 by 8. So 8 seconds is the answer. Okay. So the fundamental time period for the given cos pi by 40 minus 1 is 8 seconds. Okay. It is the answer. Okay. A single continuous time sine and cosine wave is a periodic signal. Okay. So blindly saying a single continuous time cosine and sine waves are a periodic signals. So next question, which is or periodic signal? So you see the first part x of t equal to 3 sine 4t. So what is the given signal first? It's a continuous time sinusoidal waveform. Okay, so you know all continuous time sinusoidal waveforms are periodic signal. So x of t equal to 3 sine 4t is a periodic. X of t equal to 2 sine 4 pi t. It is also a one sinusoidal signal. It is also a periodic. X of t equal to cos 3 pi t. It is also a periodic. All of the above. So these three signals are periodic signals. So the option is D is the option. So all of the above is a periodic signal. Okay. But in discrete signal, a single sine and cosine wave, it may be periodic or non-periodic. Okay. So in order to find out a single discrete time sequence is a periodic, non-periodic, we have to find out the value of f naught. That is, you see, we solved the problem, you know. Okay, so this one, in that we have to find out the value of f. If that f is a ratio of two integer means we can say that it's a periodic. Okay, if it is a discrete single sine and cosine wave, but the continuous sine and cosine wave, okay, continuous single sine and cosine wave, it's a all signals are periodic. If the signal consisting of either pi term or without pi, all of the signal, all single sine and cosine waves are a periodic signal. So all signals are periodic. Okay. Then the next question, if x1 of t equal to 2 sine pi t plus cos 4 pi t and x2 of t equal to this one, then the answer is this thing. Okay. So two signals given, x1 of t, it is the addition of one sine wave and cosine wave, and x2 of t, it is also a addition of two sine wave of different frequency. Then what is this x1 and x2? So x1 and x2 is a periodic. x1, x2 both non-periodic. x1 is periodic, x2 is non-periodic. x1 is non-periodic, x2 is periodic. Okay, so we can see. So if in a continuous thing, if the signal consisting of addition of two term means, in order to check the given signal is a periodic or not, we have to find out. Okay, so for the first part, we have to find the time period t1. For the second signal, we have to find out the time period t2. Then the ratio, this t1 by t2 is a ratio of integer means we can say that the signal is a periodic. Okay, so and that is a method in order to verify the signal is periodic or not. Okay, and one more thing. Okay, so one trick I will tell. So in order to check this addition of two signal is a periodic or not, so you see the two waveform. So in this type, if the two signal consisting of pi term means, okay, pi term means that signal is a periodic. Okay, similarly you see here sine, here also pi term is there, here also pi term is there. So the signal, it's a periodic. Okay, if the two term consisting of no pi term, okay, simply sine t, cos t means it is also a periodic. But one signal consisting of pi term, another one signal consisting of no pi term means it is a non-periodic. So here in the two thing, it is consisting of the pi term. So x1 is periodic. Similarly, the x2 is also periodic. So x1 and x2 both periodic signal. This is the condition. Okay. The ratio t1 divided by t2 is the ratio of two integer. We can say that it's a periodic signal. Then the next part, if x of t equal to 2 cos 100 pi t plus 5 sin 50 t, which one which one is correct? Okay, periodic, non-periodic, none of the above. Okay, so here, so that is a previous problem also. This one you see, it is addition of one cosine waveform and one sine waveform. So in the first cosine waveform, there is a pi term is there. In the second thing, pi term is not there. So we can say that it is a non-periodic signal. Okay, so now I'm going to prove this. Okay, so you see, you take the first signal 2 cos 100 pi t as a x1. Okay, the second signal 5 sin 50 t as a second signal x2. So in order to check this addition of the sum of these two signal is periodic, the ratio t1 divided by t2, it's a ratio of integer means it's a periodic. Okay, so from the first signal, we have to find out the time period t1. Similarly, from the second signal, we have to find out the time period t2. Okay, that is the thing. So in order to find out the time period t1, so compare the given signal with the standard cosine waveform. What is the standard cosine expression? A cos omega t. So when we are comparing these two things, So in the place of omega, okay, so in the place of omega, which one is there? 100 pi is there. So omega 1 equal to 100 pi. So what is omega 1? 2 pi f1. So 2 pi f1 equal to 100 pi. So here the 100 pi cancel. So this 2 if you are cancelling means 50. Okay, so that's why the f1 is equal to 50. So after calculating the frequency, we have to calculate the time period. So the time period is nothing but the reciprocal of frequency 1 divided by 50. Okay, so the first time period calculated. Similarly, we have to take the second signal. Okay, what is the second signal? x2 of t equal to 5 sine pi t. You just compare it with the standard sine sequence. So if you are comparing these two things, so don't worry about the amplitude, only we want the frequency term. So omega 2 equal to 50. So what is omega 2? 2 pi f2 equal to 50. So from that the f2 equal to 50 divided by 2 pi. Okay. So from that if you are taking reciprocal for this frequency, we will get the time period. So the time period t2 equal to 2 pi by 50. Okay. So t1 is calculated, t2 is calculated. Then we have to take the ratio for this t1 and t2. So therefore, the ratio T1 by T2 equal to 1 by 50, 2 pi by 50. So here this 50, 50 cancel. So we will get 1 by 2 pi. So you see this 1 by 2 pi, it is not a ratio of two integer. One is an integer, but 2 pi. So what is the value of pi? The pi is not an integer value. So the multiplication of 2 into pi is also a not an integer. So that's why the ratio T1 by T2 is not a ratio of two integer. So the given signal is said to be a non-periodic. Okay, so we proved. So this is the way. So that's why in the two signal, if both the term consisting of pi means, pi term means that pi it will cancel while calculating this ratio T1 by T2. At the time we will get the ratio of integer. Okay. But one term consisting of pi, another term doesn't consisting of that pi term means that signal it's a non-periodic signal. Okay, so the answer is non-periodic. Okay, this is the one. Then the next one is which one is a non-periodic signal. So according to this, okay, trick we can see that the first signal you see 3 sine 4t plus cos 2 pi t. So here the first term pi is not available, in second term pi is available. So it's a non-periodic. Then second you see 2 sine 4 pi t, 4 sine pi t, pi is there. So if you are calculating the ratio T1 by T2, it is a ratio of two integers. So it's a periodic signal. Okay, it is a periodic. Similarly, this is also a periodic. Okay, pi is there. In this, pi is not at all available. So this is also a periodic. Okay, so the first one, it's a non-periodic signal. Okay, one term consisting of the pi term. Okay, so or if you that is in this, or otherwise you can solve it in the previous procedure. Okay, you just solve all the problems using the above procedure. You just calculate T1 and T2. You find the ratio T1 by T2. If the T1 by T2 is the ratio of two integer means it's a periodic. So for these last three thing, we will get a periodic condition. The first thing only we will get the non-periodic. Okay, so the answer A is a non-periodic signal. And the signal x of t equal to e power minus atu of t is a non-periodic. So the statement is true or false. So e power, what is e power minus atu of t? It's an exponentially decaying signal. So this exponentially decaying signal is a periodic or non-periodic? Non-periodic. As per the definition, the signal which does not repeat after a regular interval means it's a non-periodic. Yes, okay, the true. Option A. Then the signal x of t equal to cos omega naught t is a periodic, non-periodic. So already you know all sine wave and cosine wave, a single continuous time sine and cosine wave of any frequency is a periodic signal. Okay, so periodic signal. So these parts up to this, the problems are related to periodic and non-periodic signals. Okay, so the next one, the next classification, energy power. So using the energy power, we can solve this for an energy signal. Okay, so what does it mean by energy signal? If the signal is having energy value E is some finite energy means that signal is called as an energy signal. So you see, a signal is called as an energy signal if the energy satisfies the energy value is in between 0 to infinity. That is one finite answer means we can say that a energy signal. And for energy signal, the power value equal to 0. Okay, this is the condition. So for energy signal, E equal to 0, it's wrong. T equal to infinity, power infinity, it is wrong. E equal to infinity, it is wrong. P equal to 0. So for energy signal, energy is finite. Energy, it should be finite, and the power, it should be 0. So P equal to 0 is the answer. Okay. Then for power signal, okay. So for power signal, the power value is finite and energy value is infinity. This is the condition. For one power signal, power is finite value, the energy, it should be infinity. So for power signal, what is the thing? The E equal to infinity. Okay, P equal to 0, it's wrong. Okay, P equal to infinity, it's wrong. E equal to 0, it's wrong. E equal to infinity is the correct answer. Then unit step signal is, what is unit step signal? U of t. So the unit step signal U of t is energy signal or power signal, neither energy nor power signal, none of the above. So the unit step signal, it's an example for power signal. Okay, power signal. Then the signal x of t equal to e power minus at u of t. That is the exponential signal. E power minus at u of t is a energy signal, power signal, neither energy nor power, none of the above. It's a energy signal. Okay, so we solved the problems, in that video. So if you want to learn, that is about this problem means, I will give the link in the description box. You can refer it. Okay, what is the formula in order to verify the given signal is energy or power? The energy formula is that for continuous time signal, integration minus infinity to infinity x of t the whole squared into dt. Okay, so instead of this x of t, you just substitute. If you are integrating, we will get the finite answer. Okay, so exponentially decaying signal, it's a energy signal. Okay, you can remember it. And x of t equal to a cos omega naught t plus pi is a energy signal, power signal, neither energy nor power, none of the above. So all sine and cosine waveform. Okay, if it is a sine omega naught t or a cos omega naught t, the sinusoidal waveform is a power signal. Okay, so that a power value p equal to a squared divided by 2. Okay, so this problem, all problem we solved in that particular videos. Okay, so I will give the link in the description box. You can go and refer it. Okay, or this multiple choice question, you just remember it. The cosine waveform and sine waveform, continuous. Okay, continuous cosine waveform and sine waveform. Similarly, the discrete sine and cosine is also power signal only. Okay, so you see the next one, x of t equal to a sine omega naught t plus pi. It is also a power signal. Okay, sine, in the place of omega naught, there may be some 2 pi of t. Okay, for any frequency signal, all sine and cosine waves are power signal category. Okay, the exponential signal, exponentially decaying signal, it's an energy signal. We can remember it. And the power in the signal x of t equal to 8 cos 20 pi t minus pi by 2 plus 4 sine 15 pi t is equal to. So here the x of t signal consisting of the two term. One is cosine signal, another one is sine signal of different frequency and different amplitude. This 8 is an amplitude of the cosine waveform. Okay, A1. And this 4 is the amplitude of the second sine waveform A2. So what is the power of this addition of two signal? So already you know all continuous time sine and cosine waveform. Okay, already you know the a sine omega t plus pi and a cos omega t pi, it is a power signal. Okay, with the power value already given, the power of single sine and cosine waveform is a squared divided by 2, where what is a? Amplitude. So you see the first signal 8 cos 20 pi t minus pi by 2. So this is frequency part, this is angle part. Okay, so while calculating power, so don't worry about this frequency and angle, only we want the amplitude. So you see what is the amplitude of this cosine waveform? That is a value equal to a1 value equal to 8. In the second waveform, what is the amplitude? 4. Okay, So the total power of this addition of the two signal is power of the first signal plus power of the second signal. So that's why the total power P equal to, for the first signal, what is the power? The amplitude A1, what is the value A1? 8. So 8 square divided by 2 plus what is the amplitude of the second signal? 4. 4 square divided by 2. So 8 square divided by 2, it is 32. 4 square divided by 2, it is a 8. So the addition of this thing, it's a 40 watts. So the answer is 40. Okay, so you may calculate like this. If we want to check it's a periodic or non-periodic, we have to see about the frequency part. Okay, but if it is a power signal or energy signal, we have to see the amplitude part. Okay, in a sine and cosine waveform. So for one sine and cosine waveform, the power value is a squared divided by 2. Okay, so this formula you just remember it. Then the next one, the signal x of n equal to a power n u of n is a energy signal, power signal, neither energy nor power, none of the above. So what is a power n u of n? It's a discrete time exponentially decaying sequence. Okay, so under the condition the a is in between 0 to 1. Okay, so under the condition the a is in between 0 to 1. So in the previous video also this discrete time sequence we discussed in the standard signal part. Okay, so that exponentially discrete time exponentially decaying sequence, it is a energy signal only. Okay, similar to e power minus at u of t. Okay, so e power minus at u of t, it's a exponentially decaying continuous time signal. It's a energy. Similarly, the discrete exponential signal, decaying exponential signal, it is also a energy signal. Okay, using the formula, the energy E equal to summation n equal to minus infinity to infinity x of n the whole square. So using that formula, if you are solving this means we will get the answer. Okay, energy is finite. Then the discrete ramp signal R of n. Okay, so energy, power, neither energy nor power. So the R of n, the ramp signal R of n, it is a neither energy signal nor power signal. Since if you are calculating the power, so you see, so this all calculations we done in a separate video. Okay, that is energy and power signal, energy power signal problem. We solved this one. Okay, if you are calculating the power, so the power formula is that for discrete sequence, limit n tends to infinity, 1 by 2n plus 1 summation over minus n to n x of n the whole square. Okay, and in this formula, if you are substituting this R of n value, R of n is a discrete ramp. If you are substituting, we will get the power value is infinity. Okay, similarly, if you are calculating the energy value also using this formula, the energy value is also infinity. So for the signal, both power is infinity and energy is infinity. So that's why the signal is neither energy nor power signal. It is not a category of energy signal as well as power signal. So the answer is neither energy nor power. This is the answer. Okay, so ramp signal is a neither energy signal and nor power signal. Then the discrete unit step signal is, okay, so the discrete unit step signal u of n is dash, energy, power, neither energy nor power, none of the above. It's a power signal. Okay, so you see this one, this is the calculation in order to find out the power. Okay, that is for one signal, if power is finite means it's a power signal. For one signal, the energy value is finite means it's an energy signal. So you see this is the thing calculation. So if you want to learn more about this means I will give a link in the description box and iCode also, you can refer it. So using this power formula, if you are calculating the power P equal to 1 by 2 watts, it's a finite. So the discrete unit step signal is a power signal. And the signal x of n is equal to del of n. What is del of n? It's a discrete impulse. Okay, the impulse signal, it's a energy signal, power signal, neither energy, none of the above. So the signal del of n, it's a del of n, the energy value is 1. It's a finite. So that's why it's a energy signal. Okay, so impulse signal is a energy signal. Unit step function is a power signal. Ramp signal is a neither energy nor power. Okay, it is not a category of the two things. Then sine and cosine waveform is a power signal. Exponentially decaying signal is a energy signal. Okay, so you note down. These are all the things, you just remember it. Then the next one, the signals which can be described by mathematical formula, lookup table, or some well-defined rule, or known as dash. Random signal, deterministic signal. So there is a one more category is there in the classification of signal, deterministic, random. What does mean by deterministic? Any signal which can be described by any mathematical formula or some lookup table or graphical method or some well-defined rule. We can define the particular signal at any time. In that signal, it is called as the deterministic signal. Okay, so all our standard signals, unit step, impulse, sinusoidal, that is cosine signal, rectangular pulse, signum, all standard signal we've discussed. It's a deterministic signal. Okay, so one more category, random. Random signal means the signal which cannot be described by any mathematical formula or any graphical representation. It is called as a random. So the example for the random signal is noise. The noise generated by the various amplifiers or various electronic circuits or communication circuit, it is called as a random signal. So here the signal which can be described by mathematical formula, it is known as a deterministic signal. So the B is the answer. Okay, so this is about in this video. So we discussed the three classification. One is periodic, non-periodic related question and answers, and the energy power signal, and one more thing is deterministic and random. Okay, so in the next video also, in the next part also, we are going to discuss about the classification of signal even and odd. Okay, so even and odd we will see the next video. Okay, so thanks for watching my channel, and please subscribe my channel for more videos, and please share this video to your friends also. Thank you.